All right, so hello everyone and welcome. Uh, Please let me know if you can hear me. Hopefully you can. Um, my name is Dylan Ratcliffe. I am the founder and CEO of Overmind, and in this webinar today, we're going to be talking about how to deploy safely on a Friday. Now, you probably can guess which day this picture was taken. This was, I think, 2 or 3 days before we were originally going to do the webinar. This is unsurprisingly a picture from July the 19th, the day of the massive CrowdStrike slash Microsoft, but mostly CrowdStrike outage that blue screened millions upon millions of computers and grounded flights and meant that you couldn't buy bubble tea and all kinds of terrible, terrible things. Um, and we had every intention of doing a webinar called How to Deploy Safely on Fridays, like the day, maybe the Monday or Tuesday after this happened. And so we decided that since you were all probably pretty busy from the weekend and probably didn't want to hear me talking about safely deploying on Fridays, a couple of days after you just spent the whole weekend driving to the data center, fixing 50,000 Windows servers, and we decided we'd push it back. However, I decided that this would be a perfectly good example to use for this webinar of what can go wrong and how these things can go wrong. So what we're going to do today is we're going to go through this outage and what happened. And then we're going to talk a little bit about how it relates to what we do on a day-to-day basis with Terraform managing cloud resources, and then how we can make our deployment processes safer so that we don't end up being responsible for a situation like this. So firstly, how did the CrowdStrike outage happen? Now, all of the information that I'm going to show here comes from the official CrowdStrike post-incident reviews. There were two of them. I can send out links later, but they came officially from CrowdStrike, and this is where all this information comes from. There will be a little bit of my opinion in there as well, but the facts come from the CrowdStrike details. All of these diagrams I made myself, but they're based on the information from CrowdStrike. So the Falcon sensor is deployed with this process. That's what this diagram represents. Now, the Falcon sensor is the component that caused all the problems. It's what runs on your laptop and detects for suspicious activity. And it's the thing that caused everything to blue screen. And the CrowdStrike post-incident review begins by explaining the deployment process for the Falcon sensor. And it looks like this. They start with a sensor content update. This is a new update for the Falcon sensor. That then goes into automated testing and then manual testing. And then it gets rolled out to dog food, which means they use it internally. And then it gets rolled out to a wider selection of early adopters, and then it gets made generally available. And when it's made generally available, the user then has the ability to choose which versions they want to roll out where. So in this instance, there's version N, which is the latest version, N-1 and N-2. That's what they're allowed to deploy. They choose this in the CrowdStrike GUI, and they can deploy that wherever they want. So they might deploy the latest version to dev, the next oldest version to test, and the next oldest version to prod. And so this is the deployment process. And you might be asking, okay, Dylan, well, if this is the deployment process for the Falcon sensor, how the hell did they take out 10 million computers or whatever it was on the 19th of July? Surely it would have been caught by automated testing or manual testing or dog food rollout or early adopters or N-1, this whole deployment mechanism. And you'd be right to ask that. It doesn't make sense. You would think that it would have caught that. Well, the reason that it didn't catch it is because this is not actually all that relevant to what they did on July the 19th. It was not a sensor content update. So therefore it didn't follow this process. Therefore it's not completely irrelevant, but basically irrelevant. The process that was followed is explained like this. Now this is the rapid response content process. So you have the sensor, which is how they release new versions of the actual thing that gets installed on your computer. But that process takes a while. As you can imagine, there's all this testing, internal rollouts. People can be like up to two versions behind. And so if there's some new 0-day vulnerability, they can't afford to go through this whole process. They need to release something more quickly. And so that's where this rapid response content update process comes in. They can deploy something very quickly to respond to something that might be happening now, a zero-day vulnerability. Now, this is how the process is explained in the post-incident review. There's a lot of jargon here. You're going to have to work with me. I'll explain it in a second. So firstly, the content configuration system creates a template instance. A template instance is basically just a piece of config that tells the sensor how to look for a particular suspicious thing. Those template instances then get combined together into a channel file. The channel file is a proprietary binary file format that they really don't tell us all that much about. And that gets validated and released using the content publication system. My fingers are going to get tired from air quotes. There's a lot of terminology here. That content publication system releases the new channel file out to you, the user, and your version of the Falcon sensor pulls that down and then reads it in. That's read by the content interpreter, which reads this new channel file and then sends it to the sensor detection engine, which then actually executes it and actually goes and detects the suspicious behavior that it's been told to detect. And so there's a hell of a lot of jargon in here, but it's important to note that while we're talking about content configuration systems and channel files and content publication and stuff like that, this process that happened and ended up causing the CrowdStrike incident is really not that different to the way that, say, a web server like Apache or Nginx is configured. In the case of those web servers, we have a package which is installed, which is like a pretty modular, flexible thing, which is the web server itself. It can be a web server or a load balancer or a reverse proxy. And it gets configured by one or many configuration files, which are like channel files in this instance. And those configuration files contain one or many stanzas or directives, which tell a certain piece of Apache or Nginx how to behave. And so you have many of these directives inside of many config files, which all get combined together to produce a functioning web server that does what you want. The Falcon sensor is very similar. You have lots of template instances inside of lots of channel files, which all get combined together to tell it how to look for sensitive, suspicious activity. Now, the big difference between this and Nginx or Apache is that Nginx and Apache don't run in kernel mode. Kernel mode allows the Falcon sensor to do things like intercept files before they get written to disk and check them, or do all kinds of like watching what processes do, things like that. But it also means that if anything goes wrong, the whole system dies. And that's what we saw with the blue screen of death. If Apache breaks or Nginx breaks, it just gets restarted because it's running in user mode. This is running inside in kernel mode in ring 0, which means if anything goes wrong, there's nothing else. There's nothing to protect it. The computer just switches off and has to start again. And so the consequences for failure here are quite a lot higher. Now, something you might be noticing is previously we spoke about the process for updating the Falcon sensor, where they have like all this testing and rollout and different versions and stuff. This is not really a deployment process. This is more like an architecture. It tells you how the files get from CrowdStrike's systems to your systems, like how they functionally get there, but they don't tell you how CrowdStrike makes the decision to push them. There's no mention of testing here. There's no mention of staged rollouts, no mention of N-1 releases or anything like that. So it's not really comparable to this, but this is what is written in the post-incident review. Now, in order to find out more about the actual process, what did they actually do? How did they decide? We need to look back at the timeline. So this timeline goes from, on the right-hand side, the outage on July the 19th, all the way back to February the 28th, which is when sensor version 7.11 was released. And so this is a new version of the whole sensor, which means it's gone through this process, it's got automated testing and manual testing and dog food rollout, early adopters, etc. It's a new sensor. It goes through all that. As part of this release of the new sensor, there was a new feature called inter-process communication template types, which is a template type that allows you to look at how processes are communicating, looking for suspicious activity. Now, just like if you install a new version of Apache and it comes with a new feature, that doesn't mean you'll be using it. It's just, you still have to configure it to use that new feature. And that's what this release was. There was a new feature, but it wasn't being used because there was no configuration that told it to use that feature. So that was released on the 28th of February. It went out to all of the people who had subscribed to version N, and everything was fine. Then on the 5th of March, they performed some internal stress testing for the inter-process communication template type. That's the new feature that was released in Sensor 7.11. And so this testing was basically stress testing to make sure that it wasn't going to use up all your CPU or all your memory. It's very common for antivirus things to take too many resources from the system, so they have to be very careful that doing this new analysis isn't going to affect the system negatively. And so they did all this internal stress testing on this new thing on March the 5th. Now, you might be looking at this and going, hold on, shouldn't they have done the stress testing before they released it? They're testing it after they released it. And that would be a fair judgment, I think. In their defense, they knew that nobody would be using this new feature until they switched it on. And I guess, well, they hadn't switched it on, so they just decided not to test it until they were ready. You can sort of see how this might create some misaligned incentives, though. If you've already released it, and this whole process takes, months maybe, and then you find a bug, the following week, and you have to do another release, there certainly would be some incentive to not, to underplay that bug, because you'd have to go through a whole nother release. I think there'd probably be incentives would be less misaligned if the testing was done before the release, but either way, customers weren't at risk because it wasn't switched on. So they did the testing first, and then they deployed the first thing that used that new template type on the 5th of March. And everything was fine. Nothing broke. Then from April the 8th to April the 24th, CrowdStrike deployed 3 more template instances. Remember, the template instance is the configuration that tells the new feature, the template type, how to look for suspicious things. And so they do that 3 more times, and still everything is fine. And then on July the 19th, they have 2 more changes that they want to deploy. Those changes get combined into a channel file. They get validated by the content publication system. This does some validation. Then it gets pushed out, etc. It gets read by the content interpreter, which reads the channel file and handles exceptions in the config, theoretically. And then it sends, theoretically, valid config to the sensor detection engine. And what happened on July the 19th was all of this happened. The content interpreter read it. The content interpreter said it was fine, and so it sent it to the sensor detection engine. The detection engine then tried to read a field that wasn't there and caused a memory out of bounds exception, which crashed the whole system. And it, as far as I can tell, it did that every single time immediately. It was not like a specific things had to happen. It just tried to read it and immediately crashed. So in the report, they actually talk about what gave them confidence to do that deployment on the 19th, which is really interesting. And I'm very, very glad that they included it, because it gives us a view into their decision-making process and their internal testing processes. So the 3 things that they said gave them confidence were the testing that was completed on the 5th of March, previous successful deployments in April, and trust in the content validator, that it wouldn't allow you to push out configuration that would break. Now, let's look at those in order. Firstly, testing performed on the 5th of March. This was testing that had been performed on the same feature, but not on the same piece of configuration for that feature. I certainly wouldn't deploy to production because 4 months ago, I tested a different piece of configuration that used the same vague area of my application. But this is apparently one of the things that gave them confidence to do this. I mean, in fairness, this was pretty exhaustive testing, but as we know, just because you've tried it once does not mean that a completely different piece of config many months later is going to work, because it's not the same. And it turns out that the stress testing did not use the 21st field, which this new one did. And it was that extra field that caused the out of bounds read exception. So actually the stress testing was not quite exhaustive enough. They also said that the previous successful deployments gave them confidence. Now, the fact that you deployed a similar but not quite the same piece of configuration to production 3 weeks ago personally wouldn't give me much confidence that the thing I was going to do was about to work. I would much rather say, well, I tested it on my machine and it worked, or I tested it in development and it worked. But notably, we don't see that here. We don't say, there's nothing to say they didn't test it. There's also nothing to say they didn't. Certainly, if I was writing the document, I would have included it if it had been done. There's also the trust in the content validator. The content validator is supposed to stop this sort of thing, but if you've ever configured Nginx or Apache, they also have content validators, and they will stop you from deploying content that is just wrong. Like you've put a comma in the wrong place, for example. But they won't stop you deploying content that is stupid, that is like technically makes sense, but operationally doesn't make sense because you're sending the data to the complete wrong place, or you've told it to, listen on a port that you're not actually listening on. And so this is what gave them confidence, and I have no reason to believe that they weren't actually confident. As far as I can tell, this wasn't someone who's come in as a cowboy on their first day and hit deploy. This is normal. This was a normal process that people thought would be fine because this is how they normally operate. It's a little bit concerning that it is normal to test something once that is brand new, and then in like March the 5th, April the 8th, 1 month later, deploy another change to it for only the second time ever without testing it is quite concerning personally, but that would appear to be normal. It seems that they were legitimately confident in this. Now, this is all very CrowdStrike specific, but realistically, what they're doing in deploying these rapid response content updates is not all that different to what we do when we use Terraform to manage AWS or Kubernetes or Google or Azure or whatever. We are managing many small pieces of configuration that then come together to produce overall a big, useful, complicated system. And that's what they're doing here as well. Many small template instances that get combined into bigger components that then make the sensor work. It is fundamentally a configuration change. And so if we look at the way that we normally do these configuration changes, we can see that we're already a little bit less susceptible to this sort of a problem than CrowdStrike are. So this is a pretty typical sort of Terraform workflow, where if we are managing AWS using Terraform, we will usually take a branch in our Git repository and make some changes to that Terraform code. And then we'll run a Terraform plan, which is what it looks like on the left, and it will tell us what it's going to do. So it's going to replace a resource or change some settings or whatever it's going to do as a result of our code changes. At that point, we then usually get an approval. So somebody will come in and they'll look at the code and they'll look at the plan and they'll say, all right, this makes sense. You can go ahead and approve it. And then you merge it and then you apply and it makes those changes. And probably you will do this process again and again in development and then in testing and then in production. So we're already doing a bit more testing than CrowdStrike were. But it doesn't mean that this process is without problems. So firstly, Terraform is very good at telling you what it is going to do. Like on the left here, it's telling you exactly what is going to happen. But it doesn't tell you whether or not that is a good idea. In order to know whether that's a good idea, you need experience. You need to understand whether the security group you're about to change is unused or whether it's used by your most important application. You need to understand the relationships between your infrastructure, everything that depends on the things you're changing and how they could react to it, in order to actually look at a plan and get true confidence that it is going to work. And that experience is hard earned. It's usually only possessed by a few people. Usually these are people in the SRE or platform or DevOps teams who are reasonably senior, and they've been there for a while and they understand what the infrastructure looks like, how the applications fit together, why it was done this way, what's been changed recently, all that sort of stuff. Now, the problem with that is that it doesn't scale. It's much easier to teach someone to write Terraform code than it is to teach them all of the historical information behind your internal architecture. And what that leads to is, as your use of infrastructure as code expands within your organization, more and more people are writing Terraform code, but you can't train up people on that experience quickly, if at all. And it means that those people who have the experience end up spending most of their time doing what is essentially paperwork and reviewing these pull requests to decide whether or not they are a good idea. And it's very difficult for somebody who doesn't have that experience to gain it, because it's gained usually by breaking things, and they don't want you to break things. And so it's very hard to get the experience. Also, when things actually do break, they usually break in a way that is not a simple cause and effect relationship and can still be missed by even this sort of review, where you've got experts reviewing it. Those experts will still miss things. And the things that they do miss will be a dependency of a dependency of a dependency. It's not going to be something basic. It'll be something quite complicated. So this problem is the problem that we are trying to solve here at Overmind. So now I'm going to tell you a little bit about what we do and how we're trying to solve this. So how Overmind works. Firstly, we are trying to be as easy to set up as possible. So we require a read-only role in AWS or an equivalent one in Kubernetes. And that allows us to read the status of your infrastructure, and that's all we need to do. There's no agents. We don't need any network access. We don't need any libraries. We just need a read-only role. Once we have that role, we can then discover everything that exists within your cloud environment and how it is related, or what all the dependencies are. We do that in real time. So we're not doing like a scan where we go and scan the entire thing and then save it in a database. It's always happening entirely in real time, so it's up to date. Now, because we have this ability, when it comes to Terraform, when you do a Terraform plan, you get the output that says, I'm going to change this security group and this security group. What Overmind then does is it goes and finds those security groups in AWS, or well, it doesn't have to be a security group, it can be anything, and then finds everything that depends on those resources, and everything that depends on those resources, and everything that depends on those, etc., until you have a blast radius of, here is everything that might be affected if you touch this thing. Once we have that blast radius and an understanding of the related infrastructure, we can then analyze the risks more specifically. So we can look at what you are touching, like what the resource you're touching is, what change you're making, the current state of that resource in AWS and all of the dependencies. And then we can work out what the specific risks are for your specific change within your environment. We also track those changes. So we take a snapshot before and a snapshot after so that we can work out, all right, you expected 2 things to change, but actually we saw 5. You might want to go and look at this. So I'm going to jump into a demo now and show you what it looks like. So firstly, I'm going to show you the explore side of Overmind, and then I'm going to show you the Terraform side. So on the explore side, we are interacting with this graph that Overmind is built on that can discover everything in your cloud and all of its relationships. So if I was to start by listing, say, all of the EC2 instances, we can see we've got all these 6 instances here. If I click on one, we get all the details. These details are just straight from AWS. And if I double click it, it will go and find everything related to it. So this instance has got a volume, an instance status, an image. There's actually another instance that uses the same image. If we expand that out, we can see that's also got just a single volume. They have a security group, which is actually shared among pretty much all of them. They're in the same subnet. We can sort of keep expanding outwards if we want, and discover more and more about what exists in our infrastructure. And we can do this sort of manually like this to build up a picture, or we can go as wide as we want. So if I was to say, I want you to find everything with a link depth of 10, which means find everything and then find everything related to that, and then everything related to that, do that 10 times. We end up with basically a complete picture of our account. So if I zoom out here, we can see this is all happening in real time. There's no database here. This is all querying AWS live. And so we can see here, we have this picture of the entire account. And this is the way Overmind interacts with your account. This is the way it calculates the blast radius, all that sort of stuff. Now, it doesn't have to look at all this for the blast radius. It's a bit smarter than that, but this is the technology it's built on. Now, when it comes to Terraform, I have a bit of an example here. So I have an example Terraform code base, and I'm going to go and make a change. So I'm going to go into my file here, and I'm going to change an ECS task. I know that there are some ECS task definitions in here, this one. And I'm going to make a change and change the health check from port 1234 to port 8080. I'm going to commit those changes, update health check. And I'm going to create a new pull request. And so, as I was saying, this is a fairly typical workflow where somebody goes and creates a change in Terraform, they create a pull request, and then at this point, somebody would review it. What they'd be looking at is they'd be looking at the code change to make sure that, okay, does this code change make sense? Are they doing what they said that they were going to do? And then usually you'll also run a Terraform plan, which will work out what Terraform is actually going to change inside of AWS. And you'll look at the output of that Terraform plan as well. Now, we have Terraform plan running as part of the CI jobs here. So this is Terraform plan running. We can see some output, and it's done. And so we can see in here that Terraform plan is going to change the health check from port 1234 to port 8080, which is pretty much what we expected because that's exactly what the code change was. While it is expected, it's not terribly useful. I mean, it tells us that we're going to change the health check, but it doesn't tell us whether changing the health check is a good idea or not. And so that's where Overmind comes in. So what we are going to do here is we've then sent it off to Overmind, and let me just open Overmind in another tab. And Overmind has now calculated the blast radius, and it's now calculating the risks. So we can see the blast radius here, and we can see the risks are working away. Let's have a look at the blast radius first. So this is the task definition that we were going to change. So we're changing port 1234 to 8080. I'll make that a touch bigger. However, we can see this task definition is related to a task. This is like the running task within AWS. The task has an IP address. There's a target health check, which is part of a load balancer, which points at that IP address. There is a target group, which is pointing at that. There's a load balancer rule, which is feeding traffic to that target group, which is using the health check to point at the ECS task. And so we've got, and we also see the details of the load balancer itself here. And so we've actually got a reasonably good view of the surrounding infrastructure that we need to take into account when we're making this change. As it's going, Overmind is calculating the risks for this change. So we should expect to see that reasonably soon. While we wait for this, I do just want to quickly share another screen. While we wait for this, it is worth noting that you can do this in CI, as we've done here, or you can do it locally. So rather than running Terraform plan on your, if I can spell it correctly, Terraform plan, you can also run Overmind Terraform plan, which will do exactly the same process as you just saw. It will do a plan, it will find the blast radius, it will discover the risks, etc. And so if I were to head back over to my, head back over to Overmind, which is this one. It has just finished. Excellent. So let's close these. So we can see now we have a high risk, which is red, and it's related to this task definition. So it's saying the health check command for the ECS task definition is being altered from 1234 to 8080. This could disrupt the health check progress if the port 8080 is not appropriately set up and is not listening. Verify that it's actually configured to listen on 8080, and if it's not accurate, adjust the health check or the application. Now, the reason that it is calling this out is that we can see from the other stuff that it's found that it doesn't match. Like we've changed this to port 8080, but the target health check from the load balancer is running on port 1234. We can also see the target group is sending traffic to port 1234. I think potentially there's even stuff, no, not in the rules. I don't think it doesn't contain information about the ports, but we're sending traffic to 1234. The load balancer is checking the health on 1234. It doesn't really make sense that we would change it to 8080 when nothing else is changing to 8080. And it's because of this context that we've been able to come up with this particular risk. And so what we can do with these risks, we've also found a couple of other things. So there's a few more outputs from Terraform which are a little bit concerning, like it's setting the execution role to null. Turns out that's just a Terraform thing. That doesn't actually matter, but you should definitely check. I checked and found out it's just a bug in Terraform. It always says that, but it's calling it out that this probably doesn't look right, but it's not as high of a priority as the mismatched health check ports. What we then do is we try and deliver this back into your workflow. So you don't have to go into Overmind if you don't want to. If you go back into GitHub and refresh, we can see we've delivered this straight back in as a comment on the change, updated health check. We also have an integration with Terraform Cloud, so we can deliver these risks to Terraform Cloud as well. And so the idea with Overmind here is that being able to determine what the risks are based not just on the change that you're making, but based on the context is what allows us to avoid these sorts of really massive outages. We need to be able to understand what depends on these things, what is the blast radius, what could actually go wrong in order to get legitimate confidence. And by automating the ability to find the blast radius and to assess the changes within the context of that blast radius, it means that we don't have to have your most experienced people doing all of that stuff manually. They can still review the risks and see if they make sense. But it does mean that people who don't have that experience can get what is essentially like a free pull request review that doesn't require any humans, but also they can get the information they need to understand why that's a problem, to understand how AWS is configured, what relates to the changes they're making in like an easy to understand visual sort of format, so that they can actually learn and build up this experience. And if they need to know more about it, they can say, all right, well, I want to find out about this load balancer and these rules, and they can go into Explore and find out more. If they wanted to know about their load balancers, they could, and they could go and find out about all of the listeners and all of the rules and sort of understand their infrastructure on their own. And so at this point, we've got 5 minutes or so to for any questions. So let me quickly roll back over to the slides. And does anyone have any questions? There's a Q&A thing in there. I think you can also ping me on chat. So if anyone has any questions, please chuck them in either the Q&A or DM me in the chat, and I'll go through them. Okay, so we do have one. I have one coming in the chat, which is, does this require access to my Terraform state file? It does not. So all of the information that we used in the change here, like in the blast radius, came from AWS. We took the Terraform plan, we extract all the secrets out of it, like we delete the secrets out of it. We extract just the things that are changing. So, just this service and this task definition. And then that's all that gets sent to Overmind. No state file, no code, nothing like that. All of this other data comes from AWS, which also means that if something is not managed by Terraform, we can still find it. So in this particular example, actually, Terraform manages the task definition, but it doesn't manage the task. The task is just something that gets spun up as a result of the task definition. Same goes for the IP address. You don't set the IP address, it just gets one. All of that stuff is managed by AWS. But because AWS is our source of truth, not Terraform, we can still get that stuff, which means if it was using something that was configured manually or configured in a different Terraform state or with some other automation, we can still find it. A good example of that would be you create a security group in Terraform and then 50 people go and start using that security group manually that you didn't realize because you gave it a really generic name like outbound internet access. And then when you make a change to it, suddenly you've broken 20 people's applications because you didn't realize that everyone had depended on it because it wasn't in Terraform. Now, because Overmind is using AWS as a source of truth, we would catch that. I got one more question here, which is how are the risks? Where do the risks come from? And how many things can it find risks for? So this risk, for example, is not like it's not like a formulaic thing that we came up with originally. You'll see, especially if we go back and forth. I mean, I've done this a bunch of times, but all of these risks are pretty unique, and they're unique to the specific change that you're making. Like I'm in a different one here, and we can see that this is the same change that I made in testing. We can see the risk is ever so slightly different, but it's still caught the same issue, the 8080 instead of 1234. The reason it's able to do that is because we use an LLM to come up with these risks. So the LLM is really good, all of them are, at finding the like needle in the haystack, the one difference in this massive amount of infrastructure that is problematic. And so it is used to come up with the risks, which means that there is basically an infinite number of things that it can find. And those things will not be generic. It won't be like, turning this off and on could cause downtime. I mean, you will get some of those, but they won't be high risk. It will be specific. It will have found specifically from what we found, we don't think that this is correct, and therefore therefore we think it's a risk. It is specific to the blast radius that we discovered at that time, and it's an LLM that generates it. So there's not like some fixed list. It will be able to work with any change. All right, we have 1 minute to go. I'm going to give 30 seconds for any last questions. I don't see any more. If we don't have any more, I'm going to finish off the webinar. In case we don't have any, while I'm waiting the last 30 seconds for questions, I just want to thank everyone for coming. If you're interested in knowing more, please reach out to me. I'm Dylan Ratcliffe. You can find me on LinkedIn, and you can find us through the website. If you submit a form there, it'll come straight to me. I'd love to talk to you more about it. This is all fairly new, and there's not much that does this. And so I would love for you to try it out and hear your feedback. You can always just try the CLI. As I said, you just run Overmind Terraform plan and you get this. So I would love for you to try it out, see what the risks look like in your environment, see what the blast radius looks like, and hear your feedback. It's 45 minutes past, so I'm going to end it now. Thank you, everyone, for coming, and enjoy your day. And hopefully you can use this to get a little bit more confidence and deploy on Fridays, maybe, depending on what you've got on the weekend. Enjoy, everyone. Bye.